Okay, good morning, everyone. So for this week, we will continue our discussion about Module 3. Hindi natin natapos yung norm-optimized interpolation last time. We're only able to cover, though in details, yung Chebyshev polynomials. Now, we will look at another way on how to optimize or how to make our interpolation better with respect to now a different norm. Remember, Chebyshev polynomials are the best, the roots of the Chebyshev polynomials are the best interpolatory abscissas if you want to minimize the L infinity norm of your error, right? So now we'll be looking at another type of norm for under which we want to minimize the magnitude of the error involved in the interpolation, and we will discover that again we can choose the interpolatory abscissas in such a way that this norm would be minimized, or the norm of the error will be minimized. Okay, and that's what we have here. Oh, by the way, I already updated the deadline for the first part of Lab XR 1.2 in Canvas. So I guess problems 1 and 2 are due on Wednesday right before midnight. And if we will finish Legendre interpolation today, maybe I can put up the deadline for part 2 on probably Saturday right before midnight. I hope that is okay. And then siguro move din yung Lab XR 2 kasi definitely I won't be able to finish Module 4 this week. Okay, so let's just go along and see kung ano yung optimal na scheduling for you guys. Okay, so all right, so I hope that's okay. Now let's start with definition 3 here, which defines the new norm under which we want to minimize the error incurred in our interpolation process. So this is called the L2 norm. And this is a little bit familiar with us because yung discrete version ng L2 norm is basically the Euclidean distance, the sum of the absolute error squared over the interval AB. But we will define this in a more general fashion ngayon para sa mga continuous functions, or at least mga continuous functions. Now here we define the Euclidean or the L2 norm of a function f, and we denote it this way. So meron kang magnitude bars dito, or norm bars, may subscript na 2. And this is equal to the integral over AB ng square ni f raised to the 1/2. So you take the integral of the square of your function over the interval AB, and then you take the square root of it. So ito yung L2 norm ng isang function. So you see that if f is our error term, then you can sort of deduce that this error actually is more global in nature. Remember yung L infinity norm ng error. So tingnan natin yung L infinity norm ng error. Ito equals sa supremum error over the interval AB, right? Kaya pwede natin itong tingnan as sort of a local measure of error. Kasi yung measure natin ng error ay ano yung pinakamalaking error, or ano yung magnitude, ano yung pinakamalaking magnitude ng error over the interval AB. So basically, ini-inspect natin sila point by point, tapos kino-compare natin yung magnitude ng error sa bawat isang point. Whatever the maximum error is over that interval, then that serves as our measure of error. So that's why L infinity norm is kind of a local measure of error. On the other hand, yung L2 norm is more of a measure of error. Kasi kung makikita nyo dito, ginagawa natin ay kino-compute natin yung error sa lahat ng elements ng interval AB, tapos sort of sinasum up natin sila. Remember, an integral is sort of the infinite version of a summation. So kinukuha natin yung sum ng mga error squareds over the interval AB. Okay, and then we take the square root of it, then yun yung kinukuha nating measure of error. So kung ito yung error curve, okay, yung L infinity norm ng error ay yung pinakamataas na magnitude. So ito yung L infinity error. Okay. Pero kung, so yun yung L infinity. Pero kung gusto nating tingnan yung L2 norm ng error, pagpalagay natin ito yung graph ng error squared. Okay. So yung area under the curve, ito yung nagsiserve as our measure of error. So sinasum up natin yung area ng lahat ng errors or magnitudes ng errors over the interval AB. That's why I always treat the L2 norm as a more global measure of error. So it doesn't matter kung meron siyang mataas pero scaled naman, i-consider natin yung error sa lahat ng ibang points. Okay? So that means if we want to treat the error globally and we want to get the best interpolatory function over that particular interval, we need to look at ways on how to choose the interpolatory abscissas. Again, ang goal na naman natin dito is minimize omega or the L2 norm of omega using or by choosing the exabytes optimally. So pipiliin natin ano yung interpolatory abscissas na gagamitin natin. And it turns out that these interpolatory abscissas are basically the roots of what we call the Legendre or the Legendre polynomials. So basahin ko na lang siya ng Legendre. French yata si Legendre. So, but the westernized pronunciation I think is Legendre. So kung saan kayo mas familiar. Minsan nagsiswitch ako between the two. So what are the Legendre polynomials? So the Legendre polynomials, P sub n, is a polynomial of, or is a family of polynomials such that for each non-integer n, the P sub n is defined this way in a recursive fashion, given that P0 is 1 and P1 is equal to x. So although Legendre polynomials rose from a differential equation, pero dahil hindi naman natin or hindi naman prereq sa 174 yung knowledge ng ordinary differential equations, I opted to define the Legendre polynomials right in a recursive fashion right away. Hindi ko na dinaanan yung differential equation definition niya. But essentially, the Legendre polynomials are the solution to a certain type of differential equations. But it turns out that they have a nice recursive definition. And let's take advantage of that. So ito yung pag-define ng Legendre polynomials. Again, this is a recursive formula with initial conditions P0 of 1. The degree 0 Legendre polynomial is 1. And the degree 1 Legendre polynomial is x. So if you want to get the Legendre polynomial of degree 2, so that's going to be P2 of x. So here we'll just take n equals 2. All right. So plug in natin dito. So you'll get what? You'll get 2 times 2, that's 4 minus 1, 3 over 2 x times the previous Legendre polynomial. So we are at the second Legendre polynomial, so the previous would be x minus n minus 1 over n. Remember, n is equal to 2, so we'll have 1/2. Then the Legendre polynomial 2 steps back, so that's going to be 1. So we'll have 3 halves x squared minus 1/2. That's the degree 2 Legendre polynomial. And if you will be patient enough, you can compute the first Legendre polynomials using this recursive formula. Though parami ng parami yung terms na involved. So, but if you have nothing to do and you want to check if this table is correct, so you can do the expansion for until n equals 4. Actually, you can do n equals 5 and so on. But actually, we will let our computing software do these tedious computations for us. Okay. So ito yung Legendre polynomials. Now, what are the nice properties of these Legendre polynomials? But to fully understand the concept or these properties of the Legendre polynomials, we need to look at some preliminary topics. Do you guys already took linear algebra or hindi pa? Kasi ang prereq lang ng 174 ay 152 and I think math 38. I'm not sure kung nakapag linear algebra na kayo or matrix theory. Raise show of hands. Sino nakapag linear algebra na? Oh, don't worry. Pag nag-yes kayo, hindi ko naman kayo pag-recitein.
Sir, I'm not sure, pero was AMAT 105 linear algebra po because we discussed matrices there po.
Yes. Ang AMAT 105 ay, ano ang title niya? Matrix and its applications nga ba?
Matrices and its
I forgot
applications
kasi
po
the
ata.
institute
I'm not sure din po.
Right. Na-introduce siya 2018 nga ba or 2019? Pero wala ako sa university nun. But anyway, so yeah. Some topics that you might have encountered in previous linear algebra or matrix theory courses, linear independence. So kapag ka meron kang set, or in particular if you have a set of polynomials, then they will be linearly independent if the sum of their scalar multiples will be equal to the zero polynomial whenever the CIs are all equal to zero lamang. Okay? So kung meron kang polynomials B1 hanggang Bn, tapos kinuha mo yung linear combination nila, which is basically sum ng mga scalar multiples nila. So si C1 ay scalar, si C2 ay scalar, si Cn ay scalar. You take the sum of the scalar multiples of the B subies and you equate to zero. Tapos the only possible solutions to this equation are the CIs all equal to zero. Then we say that the set is linearly independent. Kapag ka isa lang yung posibleng set of constants that can achieve this equation. And namely, that would be CIs being equal to zero for all n. Pero pag may nahanap ka na isang n-tuple of C subies na merong isang non-zero element, then the set of polynomials is not linearly independent. Or ang tawag natin ay linearly dependent sila. Okay? And then next is the set of polynomials spans a set X if every element of the set capital X can be written as a linear combination of those polynomials. So kapag kang isang set, kaya mong isulat lahat ng elements ni set X, kaya mong isulat as a linear combination ng mga elements nitong set na to, then we say that this set, the set of the B subies, spans or is a spanning set for the set X. So maganda to kasi ibig sabihin, every element of capital X can be expanded as a linear combination of the B subies. Okay. And I don't know if you have encountered the term basis, though probably this is very linear algebraic na. So a set that is linearly independent and is a spanning set for a certain vector space is called a basis. Okay. Kagandahan niya, lahat ng elements ng set kaya nating isulat as a linear combination of that set. And not just that, the elements of that set are linearly independent. Okay. Then lastly, we say that two polynomials are orthogonal over the closed interval AB with respect to a weight function W if the integral of the product of f, g, and w over the interval AB is equal to zero. Actually, right before joining the meeting, I was thinking, should I go or delve deep into these definitions? And I decided not to. So binanggit ko na lang siya dito. Baka kailanganin natin dito sa proof. But basically, you can go back to these definitions later. Probably better after you have your linear algebra topics kasi dun siya i-discuss in more details. Okay? Now, with those added terminologies, so kailangan lang natin yung definition nila. Don't worry about their implications, consequences, and so on. Because here, I listed the properties of Legendre polynomials, which might require those terms. Okay. Now we let P0, P1, and so on be the Legendre polynomials. Okay, sila yung class ng Legendre polynomials. And here are some properties. Number one, P sub n is not monic for n greater than 1. Meaning kapag ka si n ay greater than 1, yung Legendre polynomial ay may leading coefficient not equal to 1. Okay. Property number 2, it just says that the Legendre polynomials form an orthogonal set on the interval -1 to 1 with respect to the weight function 1. Kasi remember, ang definition ng orthogonal or orthogonality of polynomials or functions, pag in-integrate mo sila against each other times a weighting function, dapat ang sagot ay 0. And true enough, if you have two different Legendre polynomials, pj and pk, j being not equal to k, pag in-integrate mo sila, ang sagot daw ay 0. So that means Pj and Pk are orthogonal to each other over the interval -1 to 1 with weight function w of x is equal to 1 provided that j is not equal to k. Now, if j is equal to k, so ibig sabihin, ini-integrate lang natin yung square ng isang Legendre polynomial. The integral turns out nicely as 2 over 2j plus 1. Okay? And then property 3, yung mga Legendre polynomials, p0 until pk is linearly independent. And not just that, they are linearly independent and they span the space of all polynomials of degree at most k. So sabi rito, kolektahin lang daw pala natin lahat ng Legendre polynomial starting from degree 0 hanggang degree k, then yung set na yon ay i-span lahat ng polynomials of degree at most k. So ibig sabihin, pag binigyan ko kayo ng polynomial q of degree, say, of degree n less than k, then q can be written as a linear combination of the Legendre polynomials. So CQ, pwede kong isulat as sum ng P0 of x, oh sorry, not P0, but Pi, P sub I of x, I going from 1 to k, right? Sorry, may scalar multiplier dito, okay? So kung meron kang degree n polynomial less than k, then kaya natin siyang isulat as a linear combination of the Legendre polynomials. So you can think of it this way. Yung Legendre polynomials ay building blocks ng space of all polynomials of degree less than k. So pag kinolekta ko halimbawa si P0 hanggang si Pk, hanggang kay say P3, then lahat ng cubic polynomial and degree less, so lahat ng polynomial na may degree 3 or less, ay pwede kong isulat as a linear combination of the Legendre polynomials P0, P1, P2, until P3. And you see the power of Legendre polynomials. Kahit anong polynomial, arbitrary polynomial, lagi siyang masusulat as a linear combination of Legendre polynomials. Okay? And not just that, hindi lang na-span ng Legendre polynomials yung space of all polynomials of degree k or less. Orthogonal din yung Legendre polynomials sa lahat ng iba pang polynomial of degree less than m with respect to the weight function w of x is equal to 1. Okay? Now, medyo technical yung proof ng statement 1. I think is straightforward via the recursive definition. Makita nyo talaga pag in-expand yung hindi monic yung Legendre polynomial. I think the proof of 2 will require knowledge of the differential equation definition of Legendre polynomial. So we'll skip that. Don't worry about the proof of 2. Proof of 3 will require number 2. So we'll also skip that. Then tingnan natin yung proof ng 4. Gusto nating ipakita na yung Legendre polynomial of degree less than n ay orthogonal sa kahit na anong ang Legendre polynomial of degree n ay orthogonal sa lahat ng polynomials of degree less than n. Okay? So to prove this, edi kumuha tayo ng polynomial of degree less than n. So, pero kung meron akong polynomial q of degree less than n, sabi natin sa property 3, the set of all Legendre polynomials spans the set of polynomials of degree k or less. So, kung si q ay degree less than n, so kaya ko siyang isulat as a linear combination of polynomials of Legendre polynomials of degree 0 until degree n minus 1. So si q, pwede kong i-expand in terms of the Legendre polynomials, ci times pi, I going from 0 to n minus 1. And again, I can do this for any polynomial q kasi nga ini-span ng p0 hanggang p sub n minus 1 lahat ng polynomials of degree n minus 1 or less. Okay? And then anong gusto nating ipakita? Gusto ko ipakita na si p ay orthogonal kay q with respect to the weight function 1. So kunin ko ngayon yung integral ng p sub n times q. And I want to show that this integral will be equal to 0 over the interval -1 to 1. And let's see how it was done. Well, copy over Pn. Pero sabi nga natin si Q ay may expansion in terms of the Legendre polynomials. So palitan ko lang, si Q was replaced by the linear combination. Probably it would be better if we put a parenthesis here and closing the entire sum. Okay. Tapos, anong ginawa niya? So, ginawa niya ay si P sub n, nilagay niya doon sa loob ng summation. Because P sub n doesn't involve the index I, so pwede siyang maglabas-pasok doon sa summation. So, kaya ako nakuha itong line na to. Okay? And then I now interchange the integral, the order of the summation and the integration. Kasi linear naman ang integration. So, unahin natin mag-integrate kaysa mag-summation. And I want to do this because now I have these two guys. Pero remember, si I takes on value from 0 until n minus 1 lamang. So, okay, maybe one more step before that, ilabas ko muna yung CI. Okay, because CI is a constant, independent of the variable x. So makakalabas siya dito, pero hindi na siya makakalabas ng summation kasi involve yung variable I, which is the index of the sum. Okay. Now, the nice thing about this form is nag-integrate lang tayo ng dalawang Legendre polynomials against each other. But what do we know? We know that I takes on values from 0 until n minus 1. So, ibig sabihin, si I, imposibleng maging equal kay n. Kasi ang maximum value lang ni I ay n minus 1. Okay? So, ang sabi natin, orthogonal ang mga Legendre polynomials. Okay? So, that means the integral of a Legendre polynomial against another distinct Legendre polynomial is equal to 0. So, itong buong sum na to, buong integral na yon ay equal lang kay 0. And then here we are summing up CI's constants times 0. So what we'll get is just 0. So indeed, the Legendre polynomial is orthogonal to all polynomials of degree less than n. Okay? Any questions about the proof?
Sir, yung one part that I'm confused with is, ano po yung meaning niyo nung when you said pwedeng ilabas-pasok yung, say, C sub I? Was it that one?
As you see,
Or maybe in the
sub I.
second line. Maybe sa second line din po. Paano po natin ma-determine na pwede nating i-swap yung lugar ng summation notation tsaka yung integral sign?
Okay, thank you. Nice question, David. Yeah. Tingnan natin yung mga instances na naglabas-pasok ko ng variables. So sa summation, pwedeng maglabas-pasok ang isang constant with respect to the index. So tingnan niyo yung summation. The summation starts from I equals 0 until n minus 1. So ibig sabihin, everything with an I is treated to be a dependent variable to the summation. So kapag meron kang I na involved sa isang term inside the sum, it cannot go outside the summation. So yung CI, hindi ko siya pwedeng ilabas kasi involved yung variable I or involved yung index I. The same thing goes for P sub I. Hindi sila nakakalabas ng summation kasi yung summation ay indexed by I. So ibig sabihin, dependent itong mga to dun sa index ng summation. So I cannot put them outside of the summation. However, on the other hand, look at P sub n. Si P sub n, wala siyang involved na variable I. So hindi siya dependent dun sa index ng summation. Dahil hindi siya dependent dun sa index ng summation, this can be treated as a constant with respect to the summation. So this can simply go in the summation, katulad nito, kaya nakapasok si Pn. And in the same manner, dahil si Pn si P sub n ay hindi nagde-depend sa index I, pwede siyang lumabas ng summation. So that's why these two guys are equal to each other. Okay? And then in the next step, kapag kapag meron kang integral at saka finite summation, pwede silang mag-interchange. Remember, ang integral ng f of x plus g of x dx ay equal lamang sa integral ng f of x plus integral ng g of x because integration is a linear operator, right? So kapag meron kang finite summation, pwede mong unahin, pag kinuha mo yung integral ng isang finite summation, pwede kang mag-integrate muna, tas kunin mo yung finite summation after. So that's why I was able to reverse the order of the integration and the summation. However, be careful when this is an infinite summation or if you have a series, hindi basta-basta nag-i-interchange yung sum at saka yung integral. There are certain conditions kung kailan lang makakapag-interchange ang integral at saka ang isang infinite summation. Pero kung finite lang naman siya, mag-hold yung result natin from Math 36 na ito. Pwedeng unahin yung integral at saka yung over the summation and vice versa. Okay? And then, paano naman nakalabas yung mga CIs? Well, si CI ay constant with respect to the variable x. Kasi si CI, mga constant lang siya, di ba? And again, linearity property of integral. Kapag meron kang constant sa loob ng isang integral, so ang integral natin ay with respect to x. Si CI, wala naman siyang involved na x. So si CI, pwedeng makalabas ng integral. Kasi linear yung integral operator. So nakalabas siya dito. Kaya lang, dahil si CI ay involve yung index ng summation, yung summation natin may index 0, si CI hindi pwedeng lumabas dun sa summation. Kasi involved pa rin yung variable I, yung indexing variable I. That's why CI remained inside the summation. But true enough, this integral luckily is 0 by the orthogonality of the Legendre polynomials among themselves. So kaya times 0 na to, constant times 0, 0 lang siya. So ito ay sum ng mga 0 from 0 to n minus 1. So we get 0. Okay? So is that clear?
Apo, sir. Very clear po. Thank you.
All right. You're welcome. Now, let's see the main result. Here's the main result. Ang L2 norm daw ni omega ay nami-minimize kapag si omega ay equal sa p hat sub n plus 1. Now, hold on, guys. Now, what is p hat sub n plus 1? So remember, the Legendre polynomial p sub n is not monic when n is greater than 1. But remember, si omega yung product ng x minus the interpolatory abscissas I going from 1 to n plus 1 is monic, right? Ang leading coefficient na to ay x to the n plus 1. To make a comparison with the with the Legendre polynomials, we want the monic version of the of the Legendre polynomials. So ang kailangan lang natin gawin, i-divide si p sub n ng leading coefficient niya so that p hat, the resulting polynomial, will be monic. Ito lang yung monic version ng Legendre polynomials. Okay? Now, this theorem is telling us that mami-minimize natin yung L2 norm ni omega kapag si omega ay equal dun sa Legendre polynomials. Right? Now, this will happen if omega, remember, omega is equal to this. This will happen if omega will share the same roots as p hat sub n plus 1. Okay, so this will happen if and only if x sub i's are the roots of p hat sub n plus 1. Okay, or equivalently, roots din ng p sub n plus 1. Kasi nga, yung scaling, kasi nag-divide lang naman tayo by the leading coefficient to get p hat and p sub n plus 1 will share the same roots. And if we will force the issue that omega will have the same roots as p hat sub n plus 1, then we'll be able to minimize the L2 norm of omega. Okay, so the moral here is that we can minimize the L2 norm of omega if we will choose the x sub i's to be the roots of the degree n plus 1 Legendre polynomials. Okay, katulad din ng ginawa natin sa Chebyshev. Okay. Now, let's quickly look at the proof. I guess madali lang naman tong proof. Okay. So, again, usual trick na ginagamit natin, nagde-define ako ng intermediate function q. Pero yung function q ko ngayon ay omega minus p hat sub n plus 1. Okay? Now, what can we say about omega? Omega is degree n plus 1. P hat is degree n plus 1. So that means q is of degree at most n. Right? Kasi monic to. So ang leading term dito ay x sub n plus 1. Leading term sa p hat sub n plus 1 ay x to the n plus 1. Pag sinubtract natin sila to get the coefficient of x to the n plus 1 kay q, magiging equal kay 0. So ibig sabihin si q, wala na siyang literal coefficient equal to x to the n plus 1. So kaya ang degree niya ay at most n na lamang. Okay, so let's remember that for later. Now, compute natin yung L2 norm ni omega. Okay? So from here, we see that omega of x is equal to p sub n plus 1 hat plus q. Okay? Tapos kunin ko yung L2 norm squared ng both sides nito. So makukuha ko ito. In-square lang siya para wala tayong maging problema dun sa square root. Okay? Kaya in-square na lang natin sila both sides. And then by definition of the L2 norm squared, ito lang yan, integral nung nasa loob ng norm, quantity squared, tx. Okay? Now we expand this using your normal special product. We get this guy. Sana tama yung expansion. Yes, mukhang tama naman yung expansion. Tapos, linear naman yung integration, right? So this is the integral of a sum. So I can write this as the sum of three independent integrals. So pwede siyang integral ng p hat squared sub n plus 1 of x dx plus 2 integral ng from negative 1 to 1 ng p sub n plus 1 hat x times q of x dx plus integral from negative 1 to 1 of q of x squared dx. Right? Tapos kung makikita natin dun sa next line, nawala na etong middle term. Nawala na to. So that means this must have been equal to 0, right? Bakit siya equal to 0? Anyone? Kasi yun yung sabi dito. Bawal bumalik sa theorem 3.2.4. Bakit kaya siya naging equal kay 0? Anyone? Plus points tong recitation sa prob set.
Sir, kasi orthogonal po.
Okay. Sorry, hindi ko nakita kung sino yung sumagot. Was that Leon Grace?
Yes po, sir.
Okay, thank you, Leon. That's right. Kasi si P, ang Legendre polynomial ay orthogonal sa kahit anong polynomial na may mas maliit na degree. P sub n plus 1 has degree n, has degree n plus 1. Si Q ay degree at most n. So definitely, since orthogonal si P sa lahat ng polynomial ng may mas maliit na degree, so this term becomes 0. Okay? So that's why ito na lang yung natira. Okay? And then gusto nating ma-minimize to. Now, etong integrand na to ay laging non-negative kasi naka-square siya sa loob ng integral. So this integral then will be non-negative. Etong integrand dito ay also non-negative kasi q of x squared. So non-negative yan. Pag nag-integrate ka ng non-negative function, ang makukuha mong value ay non-negative din. Right? And remember, we want to minimize this guy. All right? So, kailan natin mami-minimize ito? Because if we will be able to minimize this guy, we will be able to minimize omega. Okay? So, any suggestion why? How? Paano natin mami-minimize yung L2 norm ni omega? Knowing that the L2 norm of omega is equal to this or is equal to this guy. No takers? So dahil alam natin na ang L2 norm ni omega squared ay equal sa L2 norm ni p hat, which is always non-negative, at saka L2 norm ni q squared, which is non-negative as well. So mami-minimize yung omega kapag ka si q or yung L2 norm ni q ay naging equal kay 0. Kasi non-negative siya. So yung minimum value niya ang magpapa-minimize dito sa sum na to. And the minimum value of the L2 norm of q is equal to 0, provided that q is the zero polynomial. Okay? So again, the L2 norm of omega will be minimized if the L2 norm of q is equal to 0, and the L2 norm will become 0 if and only if q is equal to 0. So that means q is the zero function. So dapat daw si q ay zero function. Pero ano ba si q? So si q, eto. Ganito natin define si q. So dapat daw ito ay zero function para ma-minimize natin yung L2 norm ni omega. Dahil zero siya, that means omega of x is equal to p hat sub n of x. So that means to minimize omega, it should be equal to the monic Legendre polynomial of degree n plus 1, as claimed in the theorem. So the lesson here is whenever we want to get an interpolatory polynomial that minimizes the L2 norm of omega, then we should choose the interpolatory abscissas to be the roots of the Legendre polynomial of degree n plus 1. Okay? Is that clear, guys? Clear naman?
Yes po, sir.
Okay, thank you. And then just a caveat here, the Legendre polynomials also have domain negative 1 to 1 lamang. So don't define sila to be polynomials, their domain would be the closed interval negative 1 to 1 lamang. But again, we have seen last time, and it was formally discussed in your labs yesterday, na ang interpolatory polynomial lamang ay valid over the interpolatory interval, which consists of numbers between the minimum node and the maximum node, or minimum abscissa and the maximum abscissa. But there are instances wherein we want to interpolate a function over intervals aside from negative 1 to 1. So in order to allow our interpolatory polynomial using the Legendre polynomials to be valid over larger intervals, we need to translate and scale the roots of the Legendre polynomials. And we can do so using this formula, which you already applied to the Chebyshev to the roots of the Chebyshev polynomials yesterday in your lab. Okay. So same yung formula na ginagamit, which is basically this formula is derived by using interpolation over negative 1 to 1, a linear interpolation over negative 1 to 1. So this works for anything that you want to scale up from negative 1 to 1 to an arbitrary interval AB. So kunin nyo lang yung b minus a over 2 times whatever you want to scale or translate, plus the average of a and b. Okay. Now let's look at an example. Hopefully matapos natin tong example, 3.4, wherein we consider the same function as what we considered last week, arctangent of x minus e to the x plus 0.5 plus x plus 2. But this time, the interpolation is to be done negative 5 to 3 using 11 nodes such that the error is minimized to the L2 norm. Okay? So minsan ganito ko itatago yung instruction. So hindi ko sasabihin explicitly kung ano yung nodes na gagamitin, but it should but the phrase, the error is minimized with respect to the L2 norm, should signal to you na ang kailangan yung gamiting nodes ay yung roots ng Legendre polynomial of degree 11. Kasi 11 nodes yung kailangan, and we will be getting a polynomial of degree at most 10. Okay? And then there is a pahabol na instruction, we compute for the L2 norm of omega. Okay? Now to look at to solve this example, let me share to you my MATLAB code. Sino sa inyo yung nakukumbinsi ng gumamit ng MATLAB? Sorry, hindi ako marunong mag-Python, so hindi ako pwedeng mag-shift to Python. Though pwede ko siyang pag-aralan, pero I'm very I feel more comfortable using MATLAB. So hold on. Oh, by the way, I will share with you this material, a quick introduction to MATLAB. upload ko later sa Canvas para matulungan kayo if you want to shift to MATLAB. Okay, so here I will be building up again on the code that we had been using last time. Okay. So hold on. Okay, there. Of course, line number 1, just declaring x to be a symbolic variable. And then line 3, ano yung degree ng hindi ng interpolating, pero ito yung degree ng Legendre polynomial, or basically ito yung number of points, number of abscissas. Mukhang hindi pala appropriate na tawagin natin silang degree because we can confuse it as the degree of the interpolating polynomial or degree of the Chebyshev or the Legendre nodes. The Legendre or Chebyshev polynomial. But anyway, so for us, degree equals 11 stands for the number of abscissas. So ito yung degree ng Legendre or Chebyshev polynomial. Now, kailangan ko itong baguhin. Not just Chebyshev, so gawin kong interpolatory nodes. Okay. Now, nandun pa rin yung symbolic variable t which will house the polynomials. Okay. Now, luckily, yung Legendre sa Chebyshev polynomials share the first two in their family. So parehas 1 at saka x yung degree 0 and degree 1 polynomials for Chebyshev and Legendre respectively. So kaya hindi ko na yan babaguhin. And then dun sa for loop natin last time, creating the Chebyshev polynomials, I will just replace it by the formula for the Legendre polynomials. Okay. Medyo kailangan ko lang maging careful kasi nag-adjust tayo, di ba? So kapag meron kang ti, ibig sabihin ang mafo-form natin na Legendre polynomial ay Legendre polynomial of degree, what was the degree? Of degree I minus 1, right? Pero yung formula para sa Legendre polynomial ay 2 times the degree minus 1 over the degree of the resulting Legendre polynomial. So yung n dito represents the degree of the Legendre polynomial. Pero dun sa indexing natin dito sa for loop, yung ti, siya ay degree I minus 1. So to make the thing clearer, so nag-define ako ng intermediate variable, n would be I minus 1, which is basically the degree of the current Legendre polynomial. Para alam ko na ang kailangan kong computein ay 2 times the degree minus 1 over n. Kasi pag ginawa yung I to, 2i minus 1, mamamali na kayo. Kasi yung I, siya ay degree plus 1. Right? Kasi yung indexing nga ni MATLAB nag-start sa 1, pero yung indexing ng Legendre polynomials nag-start sa 0. Okay? So this is 2 degree minus 1 over the degree times x times the previous Legendre polynomial minus degree of the current Legendre minus 1 all over the degree of the current Legendre polynomial times the Legendre polynomial 2 steps back. Okay? And we do this until degree plus 1. Okay? Kasi nga nag-a-adjust si T13, siya yung magiging degree 12 Legendre polynomial. And I will call that to be Tn. Okay? Tapos dito, pinasimplify ko lang si T sub n para ma-compare dun sa nasa notes. Pero I think I won't need that. So lagyan ko na lang siya ng semicolon. Okay? And then remember, we want the interpolatory polynomial to minimize the L2 norm. So natutunan natin yung Legendre polynomial ang magbibigay ng pinakamaliit na L2 norm. So you want the interpolatory abscissas to come from the roots of the degree 11 Legendre polynomial. So kung mapapansin nyo, itong mga susunod na lines ay galing na dun sa code natin from last week. Pinalitan ko lang ng pangalan. Remember last time, ang tawag ko ay Chebyshev roots. Dahil ngayon, it could be the roots of the Chebyshev or the roots of the Legendre polynomials. Tawagin ko na lang siyang interp roots. So ganun pa rin siya yung roots ng coef. Si coef yung coefficients ng polynomial Tn, which is the Legendre polynomial of degree 11. Okay. Tapos naglagay lang ako dito ng isang if construct kung gusto kong mag-translate ng roots. Kaya dito sa line 5, makikita nyo, meron akong translate roots. It can take value either 1 or 0. Iwa-1 ko siya pag gusto kong mag-translate. I-0 ko siya kung ayaw kong mag-translate ng roots. Dahil yung interpolatory interval natin, which I called int, so ito yung interpolatory interval, -5 to 3, so necessary na mag-translate ako ng roots ng Legendre. So that's why I put 1 here. Kasi kung makikita nyo dito, so if translate roots is equal to 1, then I will do the following things. So kailangan kong i-translate at a scale bawat roots ng Legendre polynomial na na-compute natin kanina. So I named the roots of the Legendre polynomial as interp roots, pero gusto ko silang i-update. So ibig sabihin, yung bagong laman ng interp roots would be this. Interp int of 2, ito yung second element ng vector consisting of the interpolatory interval. Let's look at that again. Interp int is equal to -5, 3. First element niya. So interp int of 1 is -5, while interp int of 2 is 3. Okay. So kaya yun yung makikita nyo dito sa translation. So this is basically b minus a all over 2 times yung former roots. So yun yung kagandahan kay MATLAB. Hindi ko na siya kailangang ilagay sa isang for loop kasi vectorize siya. So this is a scalar times a vector. So lahat lang ng elements ni interp root ay namumultiply by this constant. Plus, remember meron kang a plus b over 2, which is just the average of the maximum and the minimum value of the interpolatory the bounds, the average of the bounds of the interpolatory interval. So pwede nyo lagay interp int of 2 plus interp int of 1 all over 2. Pero average lang naman siya. So ginamit ko na lang yung command na mean. So ito ay vector plus vector. So component-wise addition lang. Scalar pala to, no? So kapag ka nag-add ka ng scalar sa isang vector, ang gagawin ni MATLAB, i-add nyo lang yung scalar sa lahat ng elements ng vector. Okay? So that's why this vectorized form will give us the new translated roots following the formula in the module. Okay? So ngayon, yung interp roots after line 29 will be translated and scaled for the interpolatory interval -5 to 3. Tapos, yun na. Ito na yung ginamit natin from Chebyshev and from 2 weeks back. So yung interp roots, kunin ko lang yung transpose niya para consistent dun sa ginamit nating code sa baba. This is still the same function that we tried to evaluate to interpolate last time. So hindi ko na siya binago. And then here's the usual Lagrange form. Tapos post-processing stuff. So we simplify P. We want to look at the pretty version of P. Tapos ginawa ko yung figure ni P over the interpolatory interval. Medyo inautomize ko na siya ng konti. Inautomate ko na siya ng konti. Remember, before I used to put here an interval of the form, ganito yung nakalagay dati, -5 to 3. -5 to 3. Yung nakalagay dito sa loob ng f-plot. Pero dahil na-define ko na yung vector -5, 3 to be the interpolatory interval, so pwedeng siya na lang yung gamitin ko doon. And then yung pangalawa, plot lang naman siya ng actual function para makita natin graphically if they do coincide or if they are close to each other. If you are generating a lot of figures, it's very advisable that you put a title to each of your plots. So the command for MATLAB to put a title on your figure is title, parentheses, then kung text or string, yung gusto nyong title, lagyan nyo ng apostrophe, then kung ano yung gusto nyong title. Here I called it plot of the function and its interpolant. And then I put a legend here para alam ko yung first function, siya ay yung interpolating polynomial P. Kasi kung nakita niyo yung figure command, unang pinaplot si P. So sa legend, unahin niyo rin yung legend para kay P. So tinawag ko siyang interpolant kay P. Nilatex command ko yung P. So if you're familiar with latex, MATLAB also can parse a latex command. And then the second legend would be for the second plot. The second plot here is this f plot, which is the plot of the function to be interpolated. So tinawag ko lang siyang function f. And then I want to tell MATLAB na dun sa mga text na nakita mo dun sa loob ng legend, latex yung syntax nila. So I need to put interpreter and then put the language latex here. Okay. Then aside from that, I want to see the plot of the absolute errors we put in here. I-comment ko muna yung 72 and 73. I'll talk about that later. So I hope you don't mind if I take another 5 to 6 minutes. If you need to go, you can do so. Just watch the remainder of the recording later. Say it's 8 minutes before time na. So I'll hit run. So tingnan natin yung interpolation, yung result ng interpolation. Okay. So of course, you have here the interpolating polynomial of degree 11. If you simplify this, makikita niyo yung nasa module. Okay. Pero it's better to look at the graph. Okay. So mas madaling i-interpret kapag ka meron ka ng graph. So here's the plot of the function and its interpolant. Medyo maliit nga lang yung symbol. So yung blue siya yung interpolating polynomial. Yung orange yung function f. But you see here that they almost coincide. Though here, medyo, I don't know if you can see it from your side, pero from my monitor, mukhang sa part na to, wait. Okay. So sa part na to, medyo nakikita ko na yung difference between the blue and the orange graphs. Pero in other portions like here, parang yung orange na lang yung nakikita ko. Kasi nga, ang ginagawa ni MATLAB, pinapatungan niya lang yung original, yung previous graphs, yung previous graph na na-plot. Okay? In this case, it seems that our interpolation is good, at least visually. Kasi over the interval -5 to 3, halos magkapatong na yung P at saka si F. And true enough, if we look at the absolute error plots, that yung absolute error plot, may kita natin na ang maximum error lang ay 0.025. Maximum absolute error ay 0.025. And this is good because we know that the function values actually here is very small. Or actually, it's not that small, pero it's near what? It's near, it's somewhere near 0 over here. Okay. So, pero yeah, it looks like, at least graphically, here in figure 1, we see that they almost coincided. And in figure 2, we see that there are very small absolute errors. Okay. Now, another measure of error is the absolute L2 relative error. Okay, or just the, what do we call this? We can call it the L2 relative error. So the L2 relative error is defined this way. Try ko kung kaya ko siyang isulat. Okay. So, ang L2 relative error is the integral over -1 to 1 ng function p minus f squared with respect to x all over integral from -1 to 1 ng f of x squared dx. Sorry, wala yung pen ko para sa laptop. Pero anyway, and kunin niyo yung square root. Ito yung L2 relative error. So kunin niyo yung L2 norm ng absolute error. So P minus F. Tapos kunin na over, i-divide natin siya sa L2 norm ng function F. So probably it's easier to look at it this way. L2 norm ng F minus P over L2 norm ni F. And this will give us a global sense of error. Ito yung percentage error over the interval over the interpolatory interval. Okay. So luckily in MATLAB, we can we can have it computed easily using these lines. Okay. Oops. Okay. So MATLAB has this command, int of a function f. So yung int stands for the integral. And then pag may gusto kang ipa-compute na integral sa kanya, input mo lang siya, ano yung function na gusto mong ipa-integrate. Say I want to integrate f over an interval. So I can put an interval ab here. So this command over here will give me the integral of f over the interval ab. Tapos pwede ko na siyang gamitin para ma-compute yung L2 relative error. And let's see how was it computed. So merong square root para dun sa square root dun sa definition ng L2 norm. Naka-square root yung buong yung quotient ng dalawang integrals. And then integral of what? So I will integrate the square of the error. So p, interpolating polynomial p that we computed, minus the actual function f, okay? And then e square ko siya. So basically, this guy is the error. I will square it. Papa-integrate ko siya kay MATLAB over the interpolatory interval. So function to be interpolated, so which is the square of the error, comma, ano yung interval kung saan ko siya i-integrate. So this is the numerator of the L2 relative error divided by the L2 norm of what is to be interpolated. So si function f, oops, sorry. Si function f, in-square ko siya. Yun yung gusto kong i-integrate because in the definition of the L2 norm, naka-square yung function to be, whose norm is to be computed, over the interpolatory interval, which we defined earlier to be -5 to 5. So ito yung denominator ko. Then let's see, let's ask MATLAB to run this. Tanggalin ko yung semicolon para makita natin yung answer. Okay. Now, if MATLAB can compute the integral exactly, ilalagay niya dito yung actual answer. Ano yung fractional form ng answer. Pero dahil binalik lang sa akin ni MATLAB yung command, ibig sabihin hindi niya na-compute yung eksakto. Pero it can do numerical integration, which we will talk about in the last part of the course. So, pero kung hindi kayang i-compute ni MATLAB yung actual symbolic integral, it can find a numerical approximation to the integrals involved by using the VPA command. That's why in line 73, I have L2 relative error to be the VPA of the previously computed L2 rel error. Hindi nga lang na-compute ni MATLAB explicitly saan siya equal, pero pwede kong ipa-numerical calculations or ipa-numerically approximate kay MATLAB ano yung L2 relative error using the VPA command. And if I run this, I'll get this. This is the L2 relative error. And this is about what? 0.0017. So that means the relative error on the average is about 1.7%. Or you can say na over the interval -5 to 3, the cumulative error is about 1.7%. Or actually, hindi pala 1.7%. Siya ay 0.17%. Which makes more sense rather than just saying na ang error ay ang maximum error ay 0.025. I don't know with respect to what is that absolute error, right? So instead of saying that the maximum error is 0.025, it might be either to say that, or it might be better to say that the L2 relative error is 0.17%. That means over the interval -5 to 3, the cumulative error is about 0.17%, which is very small, right? Now, may follow-up question dun sa module, pinapahanap ano yung L2 norm ni omega. So kailangan muna nating i-define si omega. So ano ba si omega? Siya ay product ng mga x minus exabytes. Pero yung exabytes natin dito ay roots ng translated roots ng Legendre polynomials. So anong tawag natin sa kanila? So pwede kong gawing x minus interp roots. So yung interp roots, sila yung translated roots ng Legendre polynomial. Tapos bubuuin ko yung omega. Si omega ay product ng mga yon. So kunin ko lang yung product using the command prod ng x minus the elements of interp roots. So x is scalar, interp roots is a vector. So ang gagawin lang ni MATLAB, x minus bawat isang laman ni interp roots. So x minus interp roots will be a vector consisting of x minus the translated roots. The product command will take the product of the elements of that vector. So pag multiply niya lahat ng laman ng vector na to, which is what we wanted, right? Tapos gusto kong i-integrate yung square nitong product. So kunin ko yung square niya. It's basically omega squared. Tapos gusto kong i-integrate si omega squared over the interpolatory interval. Int, right? Tapos gusto kong kunin yung square root nito. Kasi by definition, dapat may square root. Okay. And if I hit enter, I'll get a long symbolic expression because this time MATLAB was able to get the integral, the exact integral of this guy. Kaya binigay niya itong number na to. Kung gusto niyo makita ay decimal because that will make more sense, yung truncated version niya, mag-VPA lang kayo. VPA of ans will give us 7181.51, which is basically the value that you get in your module. Okay? So I guess that's it. Sorry, 2 minutes overtime again. Pero gusto ko lang talagang tapusin yung Legendre polynomials. So any questions? So I promised to upload isang maliit na file, a PDF file, which is an introduction to MATLAB in Canvas later today. And then we will move the deadline of problem set lab exer 1.2 part 2, which is problem number 3 to okay na ba sa Saturday right before midnight? Or do you need more time than that? Pero may isa na nakapag-submit ng part 2. So walang reklamo ng Saturday right before midnight? Okay, so if none, then yun na yun. And then on Thursday, we'll start module number 4, which is already on Canvas. Ka-upload ko lang sa kanya kaninang umaga. Okay? Any other questions or concerns? Kapagod ako sa discussion ngayon. Feeling ko masyado ko siyang minadali. But anyway, I hope you get the gist of the discussion. So if there are no more questions, then okay. Thank you all for joining me today. So enjoy the rest of the day, and then let's see each other again on Thursday. Bye, everyone.
Thank you, sir.
Thank you po, sir.
Okay, you're welcome.
Thank you, sir.